right, so you guys, we've been talking about exponential stuff this entire unit. So now we're going to talk a little bit about applications. This is the second last topic. So in our class on Friday, we're going to do one more topic and then we're going to start our review. You're going to have review on Friday, then Monday, and then Tuesday, a lot of review. I might go on to the next topic on Tuesday, but either way, your unit test is going to be on Wednesday. Like I keep saying, if you've done chemistry or any other science, then some of this stuff might be a little bit overlapping because there's a lot of stuff, exponential stuff in chemistry. And in science or math or financial math, the equations may look a little different, but they all mean the same thing. So the equation we're going to be using for growth and decay is A of t, which is your final amount, and then A of O, which is your original amount. So you always have final amount is equal to original amount. Then the letter B, which is your base, and that's actually going to be your growth factor or your decay factor. So it's that number you're going to be looking at to figure out if there's a growth or decay. And there's actually another calculation to do that, which will be 1 plus or minus R over 100. And I'll go over that when we do a couple of questions. And then the exponent is quite important because the exponent is T over P. So the numerator in the exponent will tell you how much time has passed, and the denominator of the exponent will tell you what the actual period of the growth or the decay is. Now, I kind of jumped into the formula without actually talking about what this means. And to give you an idea, I don't know if you guys have been following the news, but there have been a lot of things about like nuclear power plants and stuff like that, especially in Ukraine. And so one of the things about radioactive material is that they have something called a half-life. And half-life is how quickly something can decay. So unfortunately, with radioactive material, the half-life is quite great and it takes a very long time for it to decay. So if there is some sort of nuclear power plant disaster, leak, or something like that, then the area around it actually becomes uninhabitable for like years, decades, sometimes centuries, because it takes so long for that radioactive material to finally just leave planet Earth and decay away. So we're going to do a couple of examples like that. Can you think of a real life example of growth, exponential growth? Neely? Yeah, the most famous one is always bacteria. Actually, COVID, I had a great example for the COVID's growth, but I didn't have it in this handout. It was like a sub handout. I didn't include it today, but maybe we can look at it later. But really, there's been a lot of exponential growth every single time we go into a wave of COVID. You can see the growth grow exponentially. And then there's other examples, for example, like population growth, etc. Okay, so that's just setting the stage. Let's do some math. Actually, before the math. Here are the formulas for doubling and half-life. So when we're talking about doubling, our base is specifically going to be the number 2. And when we're talking about half-life, our base is specifically going to be a half. And the official definitions are doubling is the period of time during which a quantity doubles in value, and half-life is the period of time during which a quantity decays until 1/2 of it is left. Example. So let's complete the table. I have 4 examples there. We're just going to break it down and figure out what is the initial value, is it growth or decay, and what is the growth or decay rate. So we will begin with the first one. The initial value is the number in front of the base. So in this example, it would be 20. To figure out if it's something is growth or decay, you're going to be looking in your brackets. And if the number is greater than 1, it's a growth. If it's less than 1, it's a decay. So this is going to be growth. And then to figure out the rate, there's actually a logical way to do it. And then there is the way using the formula. So I'm going to show you the formula a couple of times, and then maybe we can just start using logic to figure this out. So if you look at the other sheet, I had told you that the formula for growth or decay rate is B is equal to 1 plus or minus R over 100. And the plus is used when it's a growth equation, and the minus is used when it's a decay equation. So because this is growth, we actually don't need to look at both plus or minus. We're only going to be looking at the plus. And then your B value is whatever is inside the bracket. So in this case, it's going to be 1.05 is equal to 1 plus R over 100. And if we solve for R, then we're going to get the rate of our growth or decay. So how am I going to do this? I'm going to move the 1 over to the other side. 1.05 minus 1 is just going to be 0.05 is equal to R over 100. And then I'm going to multiply 0.05 by 100. You're just basically moving the decimal place over twice. And so we get a rate of 5%. So I would say my growth rate is 5%. Okay, and you can use this formula anytime to figure out your growth or decay rate, and just know that the B value is whatever is inside the bracket. Now, that's a formula. Let me tell you logically how to do this. Remember how I said that growth is over 1 and decay is less than 1? So the number 1 represents like 100% of whatever you're looking at. So in this case, if it's 1.05, you can actually think of it as 105%. So what percent are you over 100? You're over 5%, so that is your rate. Okay, I'm going to do both scenarios for all the examples, so hopefully you can just choose whichever one you prefer. Let's look at the next one. The initial value for this is just the number 1 because there is no number in front of it. Is this growth or decay? Yeah, and how do we know it's decay? Yeah, the number is less than 1. In order for us to figure out the percent, let's go ahead and use the formula, and then we'll just try to figure it out using logic. So I'm going to go over to the side over here. 0.6 is our B value. So we're going to go 0.6 is equal to 1. Now, if it's a decay, are we going to use the plus or the minus? It's going to be minus, so minus R over 100. I'm going to move the 1 to the other side. So it's going to be 0.6 minus 1, which is negative 0.4, is equal to negative R over 100. I'll move the 100 to the other side. So we're going to get negative 40 is equal to negative R. And then we can see that our decay rate is 40%. I don't know. I will see. If you guys wanted to actually use calculators for today's lesson, that's fine. And I don't think I'm opposed to it on the test. I'll just double check with the other teachers. Might. Yeah, that's gonna be extra hard. So we calculated it. We got 40% as a decay rate. How do we figure it out using logic? So again, our number to compare the base with is always 1, which represents 100%. 0.6 is actually 60%. So from 100 to 60%, how much have you decayed? It's 40%. That's how you would get your number. All right, the next one, what is the initial value for this? 100. Is this growth or decay? Are you sure? It's actually growth because it's a number over 1. I know you were joking, right? Yeah. Oh, okay, good. And then what would be the decay rate in this, or sorry, the growth rate? Yeah, right there in the red. Yeah. Now you can go ahead and do the calculations, try it, and then let me know what you get, and then we'll figure it out logically as well. So I got 300%. I'll walk you through my logic. So again, I compare it with a base of 1, which is 100%, and this is 400%. So I know I've gone up 300%. And if you did did anyone do the calculations? Did you get 300 as well? Okay, great. All right, last part on this table. Our initial value here is 0.5. 5 over 8, is that growth or decay? Decay. That's decay. Now, for me, using logic in this case might be a little bit tricky, so we might have to use the long way to figure this out. So I'm just going to go to the side. I know my B value is 5 over 8, and I also know this is decay. So it's going to be 1 minus R over 100. I'll move the 1 over, so it'll become 5 over 8 minus 8 over 8 is equal to negative R over 100. This will be negative 3 over 8 is equal to negative R over 100. We can actually cross multiply. So when you cross multiply, you end up getting 3. What's that? And then when you reduce this, it'll be 150 over 4, which is 75 over 2. Now you can keep it as a fraction, or what's half of 75? 37.5%, right? So our rate would be, what do we say, 75 over 2, or 37.5%. A bacterial culture grows according to the formula N of T is equal to 12,000, 2 to the power of T over 4, where N of T represents the number of bacteria and T is the time measured in hours. You have to be really mindful of the units they tell you in the question and be consistent. If they say T is measured in hours, make sure all of your calculations are also in hours. Does decimal or fraction doesn't matter. Okay, so the question is saying how many bacteria are there at the beginning of time? So that means, what is our T going to be equal to? If you're talking about bacteria growth at the beginning. Yep, so our time is going to be 0. And so basically we're going to be solving this formula for when T is equal to 0. So we're going to go N of 0 is equal to 12,000 2 to the power of 0 over 4. This will be 12,000 to the 2 to the power of 0, and we're going to get just 12,000. Does it make sense that at the beginning of time, the bacteria is 12,000? Because what is the initial value in this formula? 12,000, right? So this is kind of just proving that the initial value is 12,000, because what happens is the exponent just becomes a 0, which becomes a 1. Tricky, tricky. Or not tricky, but kind of tricky. All right, on to the next one. So this is T is equal to 0. For the next one, it says after 4 hours. So I compare my units. I have 4 hours, and the question is also said hours. So that's great. All I'm going to do is I'm going to replace my T with a 4 now. So it's going to be N of 4 is equal to 12,000, 2 to the power of 4 over 4. If you're wondering, oh, can I just write the number 1? I'm going to say, just for the first step, make sure you show all of your work so I know you know where the numbers are going. Then after that, you can show however many steps you want. So 2 to the power of 1. And this is just going to be 24,000. Okay, now you got to be really careful for the next question, because the next question says after 1 day. And I recognize that now my units are not lining up. 1 day is not in hours. So we're going to have to make sure that for this question, we recognize that 1 day has 24 hours, and we're going to be substituting in 24 hours. Here's where I can get you really easily, like a question like this. It seems very simple, but if you don't make sure your units are the same, then I can get you. Not that I'm out to get you, but maybe that was the wrong word. I shouldn't have said. Sure, you can use calculators today. Oh, and then I'll confirm if you can or not. Oh yeah, this number is going to be quite big. So 2 to the power of 6 is 64, and then 12,000 times that.
768K.
Did you guys get 768,000? When will there be 96,000 bacteria? So now they're not telling us a time. They're actually telling us the amount of bacteria, and we're trying to figure out at what time will there be that much bacteria. So where am I going to plug in this number, 96,000? Yes, so this is basically my NT value is now 96,000. So when I substitute that in, it's going to be 96,000 is equal to 12,000, 2 to the power of T over 4. Ooh, now the problem is the concept we're going to learn now is actually in tomorrow's lesson. So I'm going to show it to you now, and then it will like learn it properly tomorrow. So the first thing you're going to do is you're going to go 96,000 divided by 12,000. And like I said, we're probably going to need calculators for, today's lesson at least. So that's going to be 8 is equal to 2 to the power of t over 4. Okay, so jumping ahead to tomorrow's lesson, I'm going to tell you that whenever you're solving an equation like this, if you can get the base to be the same on both sides, then all you need to do to solve the question is look at the exponents. So can I replace the 8 with a power that has 2 in it? Yeah, so I'm going to replace the 8 with 2 to the power of 3, and that's equal to 2 to the power of t over 4. And the rule is when you reach this point, 2 to the power of 3 is equal to 2 to the power of t over 4. When you reach this point, you can actually make the bases magically disappear, and you can just look at the exponents. So to solve this, we're going to go 3 is equal to t over 4, and t is going to be equal to 12 hours. All right, you guys. For question number 3, we are going to write an equation that models the situation described. Part A, the population of a town had 1,000 residents, that's the initial value, and grew at a rate of 2% per year. You can use logic to figure that out, or we can use our formula. So I'm going to just show us the formula really quickly. In this case, this is our R value. They've told us what the R value is. So our R value is 2%, and we're trying to calculate the letter B. So it's going to be 1. Now, if it grew, is that growth or decay? Obviously, it's going to be growth. So it's going to be 1 plus 2 over 100. And when you do this math, you're going to get 1.02. Do you have to show that work? No. If you kind of know that 2% of growth per year is going to result in 102, which is 1.02, that's totally fine. Okay, now when we're making our formula, if you take a look, we've always used function notation. I don't care what letters you use. You can literally use any letters you want. So I'm just going to use, do we want to stick to A? Let's stick to A. So A of t is equal to, we started with 1,000 residents. Our B value, we just calculated to be 1.02. Now, we don't know how much time has passed, right? Like the question isn't telling us the value for t, that's going to be our variable. But we do know the period of growth. And the question, and you have to look into the question to see that. Do you see the words per year? It means this much growth is happening every single year. And so our denominator is just going to have a 1, and that 1 represents 1 year. And that basically means when someone is solving this question, all of their times have to be in years now, because the original question was given to you in years. Question letter B. So the initial value of a car is 17,500. What car is 17,500? A new one? See, this is what I mean. This is very outdated. And it depreciates. You were so quick with that, everyone. That was quick. It depreciates 15%. So our R value is 15%. To calculate your B value, it's going to be 1 minus 15 over 100. And you'll do that math, and you will get 0.15. 1 minus 0.15, 0.85. Yep. Yeah, of course. Okay, so now when we're doing our equation, I'll just stick to A of t is equal to, the initial value is what? Good, 17,500. The bracket will be 0.85. We don't know how much time has gone by, but we do know that they're talking about a period of each year. So that means, and by the way, if you wrote 1, that's 1 year. But if you wanted to do it in months, that's fine as well. You could have written 12, and then you would know that all of your calculations have to be in months. Or you could have written 365, and then you know all of your calculations have to be in days. So you just have to be consistent. I like to keep it very simple. Whatever the question is asking me for, that is what I'm going to write. So if it says per year, I'm writing 1, and all of my t values will be in years. Are you guys getting the hang of it? Okay. Just as a reminder, what does the word doubling mean? Doubling is the period of time during which a population doubles in value. And we don't even really need to find the b value here, because anytime it's doubling, we know it's going to be 2. However, if we wanted to just, yeah, let's not even worry about doing the math for that. I see the word doubling, I know it's going to be 2. So it's going to be, the question is, a colony of 250 ants doubles every 2 hours. So A of T is going to be equal to, what's the initial amount? 250. The word doubling means right away your b value is going to be the number 2. And it's going to be t over 2, because now the time period it's taken is 2 hours. Okay, go ahead and try the last one. Knowing that half-life means your b value will always be a half. T is equal to, if there are 1,400 students here now, predict how many there will be in 20 years when your children. Okay. Did the word children freak everyone out? I mean, in 20 years, that's very much possible. All right. Let's. Oh, that's the shocking part. Okay. All right, you guys. So let's break this question up. We have a rate of 20%. So right away, I know I'm going to go ahead and start by solving that part. If my rate is 20%, and we're talking about increasing its growth, so when I calculate for b, it's going to be b is equal to 1 plus 20 over 100. And so our b value is just going to be 1.20. It's also told us the period they're looking at. It's every 5 years. So let's begin this question by making a general formula, just like we did before. A of t is equal to, do we know the initial amount of kids? It is, yep, 1,400. Do we know our b value? It's 1.20. We're making a general formula, so I'm just going to keep it as t for now. And then what is the period that they've given us? Yep, it's going to be 5. So this is going to be t over 5. Okay, and the question is basically asking that if in 20 years, if your kids go to school in 20 years, so how many kids, what is the question asking? Predict how many students there will be in 20 years when your children attend. So we're trying to find A of t. And what are we going to substitute for t? 20. We're going to try to do this with our calculator, you guys. So it's going to be 1,400. So it's going to be A of 20 is equal to 1,400, 1.20, 20 over 5. Maybe we can't do this without a calculator. Yeah, the numbers are too big. That's going to be 1,400, 1.20 to the power of 4. Go ahead and solve that and see what you get. I wonder who the 0.04 kid is. We're going to round that to the nearest whole number. Maybe. You guys. An isotope of strontium, SR90, has a half-life of 25 years. Does any chemistry person here want to tell us what an isotope means? No, I don't want to. Arena? Yes, yes. Let's go with that. All we need to know is There is a chemical out there, or an element out there, and it decays. It basically breaks down into half of its amount every 25 years. So let's say I started with like 100 milligrams or something. In 25 years, I will have how many milligrams? If I started with 100? 50, exactly. So you're going to have half as much in 25 years. Find the mass of strontium remaining from a sample of 80 milligrams after 125 years. Let's pretend like we don't understand chemistry at all. It's okay. We know. I don't think we have to pretend like you don't know chemistry. I think you just don't. So we know that they're talking about half-life. We know that they're talking about 25 years. We know that we have an initial amount of 80 milligrams, and they've also told us the amount of time that has passed. So let's begin doing this question by actually figuring out a general formula. So I'm going to have A of T is equal to, what's the initial amount? 80 milligrams. Do we need to calculate our B value, or do we know it from the fact that it's half-life? We know that if it's a half-life, our B value has to be a half. Okay, so that part was easy. Sorry, I'm just going to move this down. A of T is equal to 80 bracket a half. Now, let's start with a general formula. So pretend we don't know what T is. And what is the half-life period in this question? 25 years. Good. I'm hoping even without any knowledge of science, we can at least put in the values where they are, right? We should know that the initial amount's 80. We should know that half-life is a half in the bracket, and then look at the period and figure out the rest. Okay, now we're ready to solve the question. So they're telling us how much of the mass, how much of the 80 milligrams is going to be left after 125 years. So basically, we're solving this question for when time is 125, 80 bracket a half, and we're going to have 125 over 25. Oh, you good? Oh, I don't think that was. Yeah, that was. That was sheer. Okay, so I put in 125 over 25. I got the number 5. I just know, like, we should know 2 to the power of 5 is 32. So it's 80 times 1 over 32. I said you can use calculators for this. So I got 2.5 milligrams is my final answer. Did you guys get that as well? Yeah, nice-ish. Okay, last question. How long would it take for 5 milligrams of strontium 90 to remain? So in this question, they're trying to ask us to find out what the letter T is, but what if they told us, like 5 milligrams, where's that going to go? Not time, but it's going to go into A of T. Good. So we're going to now say A of T is equal to 5 milligrams. And we're going to put that into the equation that we have developed. So it's going to be 5 is equal to 80 bracket a half T over 25. And now we're trying to solve for T. Again, I will tell you that we're kind of skipping ahead to tomorrow's lesson. So if this part, like the calculation is a little bit wonky, I'm going to say just wait until tomorrow to learn it properly. The first thing we're going to do is we're going to move the 80 to the other side. So 5 divided by 80 is going to be 1 over 16 is equal to a half to the power of T to the power of 25. Yeah, the number is actually very nice. Why is that number nice? Well, can I make 1 over 16 into an exponent with a base of a half? A half to the power of what is 1 over 16? Yeah, right? Let's see if this works out. A half to the power of 4. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So it actually does work out. 1 over 16 can be replaced by a half to the power of 4, which is going to be equal to a half to the power of T over 25. And then remember what I told you in the previous question, when the bases are the same, you really just need to look at the exponents. So from this step, I'm just going to come over here. It's basically going to be 4 is equal to t over 25, and t is going to be equal to 100. And the units we have to use is years. So 100 years. You guys can cross question 6 out because we're not gonna do anything with percentages. We're just gonna stick to this stuff. Okay. You can try it. I'm trying not to get into percentages, like percent decreases and stuff. You guys, let me just tell you your homework. So there are textbook questions, page 261, numbers 1 to 15, and handout B has also been given to you. The answers are at the bottom. There aren't too many questions, so I'll just show you guys this at home so you can take a picture of it.